Find a seat.
Boost the speakers because it's not very loud.
We can what?
Boost the speakers.
I talked about it before, but apparently we don't have any control on that at all. So unfortunately, not really. Alrighty. 12 o'clock, let's continue with the next talk, which is going to be given by Daniel Barlow, and it's going to be about NixWRT, which is a collection of derivations to basically build flash images, firmwares, to flash to flash your network driver and hopefully not brick it. So yeah, give him a round of applause and enjoy the talk.
Thank you very much. Yeah, my name is Daniel Barlow. I'm here to talk about using the Nix package collection to build images for embedded routers, IoT devices, things like this little widget here, which you can't see, but don't worry, there's pictures. I'd like to start by saying welcome to London. There's a nice iconic image here of Piccadilly Square with one of our London black cabs in it. If you're not local, you might not know, they have to take a knowledge test. They have to memorize every road name within 6 miles of Charing Cross before they're allowed to drive one of these cars. Unfortunately, you can't see the contrast quite so well there. This is my iconic black X1 ThinkPad Carbon after a black cab driver ran over it the other week. So it doesn't boot anymore, surprisingly enough. Yeah, so any problems with the quality or the polish in this talk, that's what I'm blaming it on. So yeah, NixWRT or NixWRT. I came up with the name like 6 months ago and only just today realized I don't know how to pronounce it. I'm going to go with NixWRT, but I'm not going to be standard about it. So when I started out with it, it was an experiment to see if I could use the Nix package collection to build images for Wi-Fi routers of the kind you usually run OpenWRT or DDWRT or Tomato, that kind of thing on. Show of hands, I mean, who's got one of these things at home? Who's tried flashing their router at home? Fair few people, yeah. Okay, so this isn't Nixos on your router. The image you get out of it is just an image. It's immutable. You can't log into it and you know compile packages or anything like that. So it's got no compilers. Yeah. So why? Last November, I built a new computer for my home office. You see it there. It's not actually on fire. It's got LEDs inside it. And I wanted to be able to back it up. Didn't want to build another computer to back up hosts because that feels a bit sort of recursive. So I've got a USB disk drive. I've got a spare router with a USB port. So well, what if, you know, I know there's some kind of embedded Linux thing inside that router. Maybe I can repurpose that and get some use out of it instead of throwing it into e-waste. Why not use OpenWRT? And the first thing I have to say here is OpenWRT is great. And there's so much work gone into it. So many people working on different random problems which you would never even hope to be able to replicate as a small developer. You know, I didn't realize how great it was until I tried bringing the mainstream Linux kernel up on a MIPS device and found I had no Ethernet driver. And a router with no Ethernet driver is a little bit, it doesn't root much. Yeah. However, I'm not going to be telling anyone anything you don't already know, but when you're talking about divergent, convergent, and congruent change management, OpenWRT is on the left-hand end of the scale to a big extent. You know, you have 60 billion different packages in OpenWRT. You install them imperatively by typing commands on the thing itself. Then you configure it using a GUI. 6 months later, you upgrade the firmware, or the router blows up and you need new hardware, or your ISP says try factory resetting it. And can you remember everything you did? Maybe some people are diligent enough to back these things up properly, but I'm certainly not. So I got to thinking, maybe there is a more general problem to be solved here than just somewhere safe to store my RIP CDs. So yeah, did some hacking, did some blogging, got distracted again, got my laptop crashed, and managed to crash my own home network in several different fun ways. Here we are a year on. Is it done? There's a little bit of scope creep. I did the backup server. The backup server is working fine. That's great. I did what I came for. I repurposed the wireless range extender in my study upstairs to run NixWRT as well. The router downstairs, which is the one that actually connects to broadband, I'm still working on that. Take over the world is kind of a stretch goal. And the other question, I said it was an experiment, so what were the findings, I guess? Is Nix good for this stuff? And emphatically, yes, it is. Okay, I'm kind of preaching to the converted. But the Nix language, I mean, it's, compared to anything else I've used in terms of, configuration management or building is superb. Everyone knows that. The cross-compilation stuff, you might not know unless you've been involved with it, but as of sort of beginning of 2018, a lot of work being done last year on cross-compilation in Nix, and it's really made it easy to build MIPS binaries from an x86 system. And the support for Muzzle, which is an alternative C library to the GNU C library. It's smaller and faster and more compliant and works better on embedded systems. And I think that's pretty new as well. It's certainly the case that I've hardly ever hit problems trying to use a C library that's not the GNU C library. So on those three counts, on those three counts, Nix is pretty awesome. Overlays. Again, there were various ways of customizing derivations before overlays came in, but having a consistent way of doing it that's reasonably principled is really useful and really helpful for making packages smaller. And I will talk a lot more about that in a minute. Yeah. There are things I have learned along the way that if you wanted to get into it, you would also end up learning sooner or later. How to read and write Nix derivations, stuff about Linux, stuff about how the kernel is put together, things about networks, switches, TCP, Ethernet, what's a MAC, what's a PHY, overlays, fixed points. Fixed points are awesome. I know enough to hand wave about them. I don't know enough to explain them, so I'm going to do some hand waving in a minute. If you have enough coffee, the rest of it is easy. So what do you actually need? Obviously, you need some kind of thing to run it on. This is the GL iNet MT300N, which is like GL iNet MT300A, but it's a different color. It's slightly cheaper, and the hardware inside it's slightly different. These are not your typical PCs. They're smaller, they're slower. No graphics hardware, so I establish a console connection to it by attaching 3 wires to it, which is more or less complicated depending on whether there are pin headers there to attach them to, or you need to go and do some bad soldering. Obviously, the architecture is different. It runs some variety of MIPS, or the ones I've tried so far do anyway. I guess some people are using ARM for this stuff. You don't boot from the BIOS or from UEFI. You don't use grub. You use a thing called U-boot, which I'll be showing you in a minute. And the way the particular board knows about all the bits that are in it, like where the GPIO pins are, where the LEDs are, how to make the Ethernet, how to initialize the little network switch inside it. On a grown-up computer like a PC, you've got things like ACPI, where it can sort of go and enumerate the bus and find out where all the things are, because all the things will say, look, I'm over here. On these older, smaller systems, either that knowledge is compiled into the kernel for the particular board you're using, or on some varieties there's something called a device tree, which is basically a data file with the same information in it. So we abstracted that code into data. The device tree is a better way of doing it, but not all ports have been updated to use it yet. Yeah, so in terms of NixWRT, if you wanted to play with it, the best supported boards are the ones based on the AR9330 or the ones based on the MediaTek SOCs. And I say the blue one and the yellow one are both cheap and both easy to get hold of, and also no soldering required. You just pop the top off. Is there an emulator? QEMU works, but the hardware emulates not very much like the real hardware. Testing on the real hardware is actually not that bad. So, obviously you need to connect it together to something. This is my test setup. It's a little bit more baroque than it needs to be. That you'll see is the device itself with 3 cables coming out of it for the serial console. Serial console is TTL level logic. It runs into something which understands that. In my case, at the moment, that's a Raspberry Pi because I blew up my serial cable. And then that is the most overkill use ever of an Arduino YUN, which basically exists to toggle the USB power off and off. So when I wedge it solid, I can turn it off and on again without having to go upstairs and pull the USB cable out. So I'm going to do a little demonstration of what it looks like to build on, or what the actual hardware looks like. I'm not going to demo it on this thing here because it would take too long to plug everything together. I'm going to attempt to SSH into my system at home and show you it there. You ask what could go wrong. Well, this guy here actually, my son, has got to the age where he really likes turning the power on and off in the front of the machine. So hopefully it's still there when we get there. We're just about to go and find out. Right. Nope. That's not it either, is it? Ah, it was that one. Okay. So let's have 80 columns as the good Lord intended. My handle on most online system is Telent, which I chose a long time ago because I couldn't type Telnet correctly without typoing it. So the host name theme is all typos as well. Here we are. I'm going to start by making it. And it does nothing, of course, because I made it last night to check that everything worked. And therefore there's nothing to be done. So there's a little make file, just because there's an awful lot of parameters to give to Nix builds. So the particular derivation we're using, I'll show you that in a minute, it's called backup host. We're building a target called firmware. Various parameters we're passing it for things like SSH keys and an rsync password and other stuff. And you'll see it has eventually built a file in that directory there. And then it's rsynced it into my TFTP server directory. And I'm just going to show you that yeah, there it is. So that is my firmware file, which is about 4.5 megabytes in size, which is okay for that particular target device. Put that back in the stand. Good. So I'm going to introduce some insignificant white space into one of these derivations. Oh, that's nice. No, all right, I'll come back to that bit. Here we are. So this is that volume level okay for everyone? Yeah. So this is the device itself. I'm connected to it over an SSH section, over an SSH section, over a Minicom serial session, over the 3 wires you saw in the picture, into the hardware device. I'm just going to reset it just to show you it's there, and I'm going to stop auto boot. So this is this thing called U-boot. It's the universal bootloader. It's called the universal bootloader. What actually happens is that hardware manufacturers take it, fork it, hack it up, burn it onto their machines. Getting a new version of U-boot onto your device is a bit like trying to put core boot onto your laptop. It can be done, but if it goes wrong, you need JTAG debuggers and stuff like that. So, generally speaking, the one you've got is the one you're going to live with, unless you want to get more complicated than I've got. So anyway, you've got a collection of commands in U-boot here, which do things like print the environment variable, boot, change memory addresses, let you do things with flash and so on. So if I just do printenv, they are more or less defective depending on the manufacturer. So in theory, if you've done a proper good install of U-boot, then this environment will be writable and you can change the parameters here. Often you'll find that the hardware manufacturers just hard-coded the environment and you can't actually save anything, which is annoying, but not insuperable. So I'm going to boot this device, and I'm going to do it the slightly cheesy way by inserting a file, empty boot.script, because there's about 5 or 6 lines I have to type to get it to boot from RAM. Oh, okay, off it goes. Okay, and then it's doing exciting stuff. Just going back through the scroll back here in Tmux. Quite a lot of it. So what did it do? These are all U-boot commands it's typing in. It's booting the TFTP. It's there's the TFTP command. It's copying it into a particular start address, which is carefully chosen not to clash with anything else. And then the bootem command is a boot from memory. So there you see the TFTP happening. There it's loading the thing down. That's where it's... Sorry, I'm pointing at my screen instead of your screen. That's the actual where Linux actually starts happening and starting kernel, and the rest of it is all Linux. And there it is. And just to show you that we're not in x86 anymore, yes, it is running root shell on the console. This could be considered a security problem if your threat model includes people prying the covers off and attaching 3 wires to the... that can be configured, of course. So there we are. It's a MediaTek MT7620 GL3 MT200A. It's running on a MIPS. It's 385 Bogger MIPS if they count for anything anymore, and various other stuff there. That concludes the demonstration, I think, probably. So how does it work? I don't know if any of that writing is readable from where anyone is sitting. It surprisingly took longer to draw that than I thought it was going to. So what I'd like you to focus on here is, this is a description of the build process. This is our output at the bottom, which is the firmware binary that we just saw being TFTP booted. In that image, you've got a kernel image, which is this U-image thing here. You've got a file system image for the root file system, and the two of them basically just splattered together with DD. file system image is generated from a configuration, which is a Nix value I'll show you in a moment, which has got, it's an attribute set with various different things you want to go into your image, and the image builder then makes the image out of it. Some of the things, I'm going to talk about modules in a minute. I know a lot of people talk about modules. These aren't NixOS modules, these are something else. I named them badly. So you start with an empty configuration, you apply modules to it until you've got the config you want, and then you send it into the builder and it builds your image. Some of the things in your configuration are package references, so we also set Nix packages out of there. We've got an overlay to make them smaller and and so on. The other half of the picture is the kernel build, which comes from the kernel.org, the upstream. It also comes from OpenWRT. They get merged together, it gets built, we get the VM Linux file out of it, we stick the device tree into it, which is the data file I was telling you about earlier. That gets you the bootable image, and so that's the other half of the output there. So I think the three things in that picture which you would have to touch if you're hacking on this are the package overlay for including packages and making sure your packages are going to build on it, the module system, which is badly named, and potentially the kernel build if you want to get detailed about it. And we're going to have a look at each of those. So there's good news. There's lots of good news. Lots of Nix packages already just works, which is awesome. We quite often have to patch our packages because we're not using the standard C library. Some things don't cross-compile, so we need to disable the do check clauses where they're in if they're unconditional. Sometimes you get very big closures. Malco was talking about big closures yesterday, and I really feel it on this thing because we have a very limited amount of flash space. It can be as little as 4 megabytes. You don't want to be getting 1.5 gigabytes of Firefox in there. So there are various hacks we've done to remove library dependencies for optional features where the original derivation included them. Get rid of shell scripts that depend on bash because bash is huge. If all else fails, just run strings and grep for Nix store. That's a good way of finding leaky bits in your closures. Make sure you stripped everything, and we also slightly hacked up the squashfs generation to remove static libraries from the generated output because who is ever going to use those when you don't have a compiler? So here's an example. This is one of the entries in our package overlay for the host app daemon. As you see, it's based on the upstream one of Nix packages. We've overridden the SQLite attribute because we don't need it. We've the SQLite parameter we've overridden. Then we've gone to override the attributes as well, and we said we don't want extra config, and we're going to use this configure file, which we generated here, instead of using what the Nix packages one does. And that's a huge saving on host appd, and that's how I've got a wireless extender running in 4 megs of flash. Modules, not the NixOS module system. We've had a lot this couple of days about the module system. The chief reason for writing it differently was that it seemed like fun. Middlewares might be a better name. A module is a function which applies to a configuration and generates a new configuration. And we apply them repeatedly in the same kind of pattern as overlays do, except we're applying them to the configuration rather than applying them to the Nix package derivation. So your configuration object, that's really bad. I don't have a picture of the configuration object. Ooh, wow. Skip forward a little bit there. What's it doing? Hey, right, okay. There's reveal.js. It's three-dimensional slide navigation. It's funky. So the essence of it is that in your derivation, you'll start with the base configuration, which has almost nothing in it. It has empty arrays of files, packages, some other stuff. You will then apply each module in sequence to it. So that's the hardware module for the device. That's going to include an rsync server. That's going to include an SSH server. That's going to include BusyBox, which is pretty fundamental. This particular device is my backup host, so it's got a USB disk module in it with some parameters. There's some stuff for the kernel. There's some stuff for configuring the network switch, which is integrated into the device. And we're running syslogd, we're running NTPD, we're running a DHCP client. And to build the firmware, we merge all the modules together and pass it to the firmware generation function, and there's our firmware.bin. The modules themselves actually look like this. You see the whole fixed point pattern up here with the self and the super. La 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 la. So that's our parent module. We're adding a service called hostappd. We're adding the hostappd package, and we're adding this is right down at the bottom. I don't know if anyone can see over his head. Right down at the bottom, we're adding a file called etc.hostappd.psk, which has also got some content and a mode in it. And those files are written into Flash, same as everything else. I'm running out of time to talk about adding new hardware devices, which is great because this is the complicated bit, and I'm going to skim through it. New hardware devices, I think I've had it running on 4 different devices so far, which are all sort of 1 or 2 of the various MIPS families. It is much, much, much easier if it already works in OpenWRT. In fact, I wouldn't even bother trying it unless you want a project to try and build for something that isn't in OpenWRT already. There's kind of things you'll expect to have to do is find out what stock family it runs on. Is it Atheros? Is it an RA link? Is it MediaTek? Is it something else? Because that's going to impact whether it uses device tree or something else. Find out how to attach a serial cable to it. I've burnt one router by doing some really bad soldering on it already. As I say, does it use the device tree? And then you find out things like where in memory is the flash? How do I configure the network switch such that the Ethernet in the kernel actually gets out to the box? All of this information for all the supported devices is in the file called devices.nix. And there's a lot of commentary in there as well. If you are minded to do your own device, you would do that. And yeah, if you can cobble together something to turn its power on and off remotely, you'll find remote development a lot easier for the early stages to bring up. I can show you my Arduino. It's not pretty, but it was stuff I had around. So future plans. Obviously, the first thing to do is to finish the PPP over Ethernet supports, because then I can actually run it on my primary router at home, which the family will love, I'm sure, when it starts crashing. Better story for upgrades. I've got a plan for upgrading without having to flash it every time. Better story for the first-time support, which doesn't involve attaching cables to the device. That's going to depend on the device, because your vendor firmware may allow you to upgrade freely or may have restrictions on the format, so that's going to be a bit of fun working it out. And a better story for secrets. So at the moment we don't put secrets in the Nix store on the build machine. I've been quite careful about that because I check that into GitHub. But they do end up burned into the image. And if you want to change your password, then you end up having to reflash the image, which doesn't feel quite right. So design something which will get them for a writable file system or over a network or something else. I can quite see the appeal of network-based secrets if you're managing a decent-sized fleet of devices. And perhaps even get some users, because at the moment it's just me. So that's it. 2 minutes for questions. Ask me anything. I may not know the answer. I can probably hand wave.
Alrighty, thank you for your talk. Who has got questions? Yes, we've got a question.
I have a pile of WRT54GL routers up in my attic. Is the 4 megabytes of RAM, is that, it looked like your image was a little bit bigger. Is there a little bit more that could be cut to get this running on them?
That image is bigger than the smallest picture I have running has 4 megabytes of flash, and that's the wireless extender upstairs. I had to work quite hard to get it into 4 megs, but things can be done with the 4 meg image, yeah.
More people with stuff in their basement?
Sorry?
Hello, thanks for the talk. I'm wondering about whether we can implement DM Verity onto this. DM Verity, like the Merkle hash trees, just to check the hashes of the file system.
It's not something I've thought about. It would be a good idea, yeah.
Another question? Nope. Then, Daniel, thank you very much again for your wonderful talk.
Thank you.
Next up, we've got. Can everybody talk? Well, there have been 6 slots, and these have been filled already. So, so yeah. Oh, and also, by the way, if you are a presenter and you are aware of the fact that you're presenting, maybe seat yourself over there so we can make sure that it also runs more or less smoothly, right?
Okay.
Okay.
Cool. Seems to work. Right. It's just hard. Oh well.
Right. Is the mic on? Yes, I guess. Yes. Okay. Off you go.
All right. Annoying. Can everybody hear me? Okay. I just wanted to quickly present Skilla, which is something that I've worked on for the last few weeks, or maybe 2 months already, which is another Nix-based CI. This time it should be open source. So basically, all it tries to do is building Nix projects that you have with a default on Nix or some other derivations, and not do anything else. The reason why I'm doing this is basically because I tried to set up Hydra and make it work the way that I would like to have it work, and also introduce other people that wanted to use CI for Nix, and they just couldn't understand a thing about the configuration of Hydra. So instead of having CI that is hard to configure for a lot of people, I wanted to have something better. So the problem with Hydra that I see is that you have this huge CI instance and you try to configure it, and you have a lot of people that want to configure it. But if you have, I don't know, 400 people that each have a project, it's a bit difficult to coordinate. So I tried to turn this on its head. Okay, let's do this. So that is my main problem with Hydra. Otherwise, I find it amazing, but yeah, we eventually have to replicate the functionality in another way. So instead, I made Skilla, which is like an inverted Hydra. The configuration comes from the repositories, and it's basically pushed alongside with the push hooks that you can set up in GitLab or GitHub. And every time you make a PR or make a commit to a PR, it runs the CI for you. and then it pushes the build results to your cache. So in the best case, all you need to have is one derivation, and that's your whole setup for the CI, except for setting up the hook. For my use case, it's basically because we have in our company, I don't know, 350 teams that each want to have their own CI setup, and trying to get them to use something like Hydra was too hard. What else is there? Yeah, the other thing that I wanted to use Hercules, but there was the requirement that also the cache needs to be on premise. And yeah, that's the reason why I started this even after hearing about Hercules. That's an example of the CI Nix file that you can write. So basically all the derivations that are at top level will be evaluated and then built and then pushed to the cache. And that's pretty much all it does, except for updating your GitHub status with any errors that happen. And I also built a UI with display for the logs and listing of the projects and builds and stuff like that. Yeah, so the backend is implemented using Go and PostgreSQL. The queue implementation is also in PostgreSQL, which might be a bit unconventional, but it works well for me. Yeah, it's designed to run in a Docker container, so you can have as many instances of Skilla running as you want, and each can have their own setup and their own database, and they can run in parallel. Yeah, the builders themselves have to run on a more conventional Nix setup because I want to have sandboxes. And yeah, getting that to work in Docker was pretty much impossible, except when you have a privileged container, which is not something I can have on our Kubernetes cluster. Okay, so that's pretty much it. You can go to this URL to check out the source. If you actually want to try it, you might reach me on IRC with my nickname Manru, because it requires a little bit of setup that I haven't documented fully yet. And that's a bit about the future work. You'll have to watch the stream because my time is out. So, see you.
Hi, can you hear me? Yes. Okay, I'm here to talk a few minutes about the Nixos wiki. I'll try to stay below 3 minutes to get you to lunch. So most of you probably know the story about the Nixos wikis, more than one. We had the old official wiki that was basically put in read-only mode some time ago. Then there was a short discussion on GitHub what to do with it. Most of you probably participated in that. Yeah, some people started the Nixos users wiki on GitHub. To be honest, I really dislike the GitHub wiki style, and I did not want to use it because it felt, yeah, not like a wiki that I want to use. Then we had this event, like the links were completely removed from the website, and people were looking for the old read-only wiki, and it was basically gone. And then I started the new Nixos wiki, the unofficial one, as kind of replacement. Yes, there's a detailed history available in the wiki itself. So some figures I will present to you, just to provide you some background. There's basically no logging on the wiki, so we don't have proper numbers. They are all taken from the Google Webmaster Tools, because that's the only source of numbers I had available. Yeah, they were always representing a range of 3 months before I extracted them. So I want to give you an impression with that, what is often looked at in the wiki. Those are the top queries leading to the wiki. Apparently Nixos and Docker is an interesting thing, and people like to game on Nixos with Steam. So other stuff like ZFS, Raspberry Pi, and so on, you can see the list yourself. So those might be topics that we might want to expand on in the future on the Nixos wiki, because many people are looking at it. Some graph showing how often the Nixos wiki is shown in Google search results, like in 3 months, nearly 350,000 times. It's displayed, only 28,000 clicks. So, but there seems to be some interest in the Nixos wiki, or whatever is written in it. The top pages of the wiki, of course, the cheat sheet. Yeah. Then we have something that's a bit odd. Like some pages have way more expressions than are appropriate for the number of clicks. But those might be pages we want to work on, especially the FAQ, the create and debug packages. Perhaps we should even think about extending the official documentation, especially around the package creation, if people are looking it up in the wiki instead of the documentation. So that's one thing to think about. Countries from the visitors, United States, Germany, France, are on the top of the list. So, but we are quite an international crowd. The registered users on the wiki, so there's a steady growth. Keep registering, keep adding content. Some technical information, it's hosted on a small VPS at Vultr. It's managed via NixOps, everything except the MediaWiki part that is being worked on. If anybody wants to help long-term with that, not just like a one-off thing, please talk to me. People that fear the content might be lost someday, there's a daily dump you can download. Some people already do it, like every night. And for the future, it's planned to put a CDN in front of the wiki to make it faster outside of Europe. Yes, and that's it. Thanks to all the wiki contributors.
Hey, I'm Lassulus. I'm talking to you about Nix writers. They are basically like, have you ever used like write script in NixOS? And Nix writers are basically the same thought, like put through, like write every language you like, not just bash scripts. So for example, one can write C like this, put it inside the Nix REPL, build it, whoops. Yeah, first of course we have to import it. And then we have to paste it again, because Nix REPL does some crazy stuff with new lines and history. And then we have like this derivation here, and we can see it's a binary, and we can just run it and hello world comes out. And also the same for Haskell, like people sometimes want to write Haskell and there's a lot of boilerplate you have to write. But with Nix writers, it's basically just these couple of lines, build them. Whoops.
You stole our hacker from project.
What project? Yeah. Okay. And okay. And then yeah, you can just run it. Yeah. there are also like other languages available, like these are which we have already packaged, and yeah, I guess the thought is clear. You can see the implementation. It's like here on this side. There's also some documentation about it, minimal, and I guess that's it. Any questions for? Yeah, that was the thought of it. I wanted to clean it up, and then I make a pull request, and then if somebody merges it, it's in Nix packages, I guess. Okay.
Thank you.
Okay. So hello, I'm Gleb. I work at Digital Asset. We are using Nix for our development environment, and I wanted to give you a quick rundown of our devenv. As Rob previously presented, like it's a good way to introduce Nix in some companies, to wrap it in something which just works very clean, and users don't have to understand what's inside. So that's exactly what we do. All of the kudos go to UC Maki, who actually did all the hard work. I'm just maintaining it nowadays. So let's say I am a new developer in our company, and I start on my first day. I get instruction, install direnv. Jonas, awesome tool, thank you. And then I check out the code. I go to, actually, let me assume that I don't have Nix installed. I go to our repo. It tries to load the development environment, but it tells me that Nix installation might be invalid and asks me to install our so-called devenv. So I do that with the tool, which just does it for me. I run it, I wait. So it will take like 30 seconds on this connection. And why we're doing this? So why this devenv is different from others, because probably many of you have something similar in your companies. Our company is very diverse in terms of technological choices. There are people who do Isabelle theorem proving. There are people who are doing Python scripts or JavaScript and everything in between. So we cannot just use Nix shell, because that would mean that everybody have to download everything, and everything is like 10 gigs of tooling. So we had to solve this somehow, so people don't have to wait for like an hour every single time we update our Nix packages snapshot. So we had to, UC implemented a lazy layer on top of Nix tooling to kind of download tools on demand when need be. So while I was waiting, the whole thing downloaded. So let's force DRAM to reload it. Now I have my path have changed, and a couple of other variables have changed. And if I would like to, let's say, call SBT to build some Scala, I can see that SBT now is loaded from devenv bin SBT. And actually, when I call it, it's a wrapper script which downloads a bunch of things which are necessary to run SBT, and does some. And this is done completely in the background. If I run SBT again, actual SBT runs right away. It's just slow. That is SBT, and the same goes for things like JQ or any other tools, JO, or we even put htop inside, because I know there is nothing better on macOS, and we support Linux and macOS, so we need to make sure that all devenv tools are actually portable, or we have different versions on Linux and macOS, and they work the same. We use the same devenv, the same set of tools on workstations and on CI. So when something works on your machine, it will work on CI. And we don't. Many people go in direction of containers. We solve it with Nix. Okay, And I wanted to, I said that I wanted to make this as clean and visible as possible from users. So for example, if somebody wants to add a new tool, it's extremely trivial. They need to create a stupid wrapper, a symlink in a directory, and add one line to expose this tool into the devenv, and that's it. That's all the user needs to do, and it's completely transparent for them. The problem is, how do they find the appropriate attribute path? But that's why we have a Slack channel where we help them with that if need be. But many non-Nixers have contributed significantly in terms of set of packages which you expose. And this thing is used by like 95% of the company. People are pretty happy with it, except for every single macOS upgrade. It's a disaster. So I've been working on this most of this conference. Yeah, and I mean, we're happy with Nix. We'll definitely be using it. I'm hiring. We use Nix, Haskell. We use backend Bazel. So if you want to work on these topics in London, New York, Zurich, or Budapest, talk to me. Thank you.
Hi. All right. So on the topic of Nix and Haskell, John Weagley, the maintainer of Emacs, started an alternative implementation of Nix in Haskell. It's called HNix. Right now it's a parser, complete parser. It's a, yeah, not so complete evaluator, but quite there. And it's experimenting with type checking as well, although it's not there yet. Yeah, that's kind of the current state. It also has a pretty printer for Nix. Yeah, it's hosted on GitHub, and yeah, there's some docs how to get started. It passes all the Nix packages, the Nix tests, and so on. So I'm gonna show you what you can do with it today. We have Nix on the left, the Nix, and HNix on the right. So for example, if you do this in Nix, you will get just that an attribute A is missing, which is a constant pain during development. HNix will yeah, show you the actual attribute that you're trying to look up, and gives you a bit more information. There are still some errors that are not that great. For example, if you do something like this, yeah, it's still needs room. There's still room for improvements. So one of the goals of HNix, there is no official roadmap, but one of the goals is to provide a better user experience, and this comes to error messages and other things, and to provide good tooling so we could create, for example, there is very good support of creating interactive debugger that you could go to different stacks in the stack trace and see what are the variables inside, and figure out, you know, what went wrong. Of course, for infinite recursion error, that's not that helpful, but for everything else, it should be. As I've said, it also has a formatter, so you can just run it like, if I have a file like this, it's pretty, let me just, so it has a pretty printer, and it kind of works. There's just one problem, and I'll show you, which is what I want to hack on tomorrow. So yeah, this is a simple file from Nix packages, and if you run it, it will pretty print it. The only problem is it strips comments at the moment. It doesn't support comments. So this is something I want to add. It's not that trivial because comments can appear pretty much everywhere. But it formats it pretty nicely. Let me show you another thing. So if you do a typo, for example, here, yeah, it will show you where the actuals in source where the problem is, and it will tell you I expected this. No, I got unexpected character, and I got I expected this for 3 things. This is all basically Haskell libraries by default do very good job for parsing and so on. So yeah, I would recommend it to try it out for error messages, and if you think that can be improved, open an issue. And for pre-printing, once the comments work. The evaluation itself, it doesn't actually provide the correct hashes for the Nix, so it's not that useful yet. That's they have a hackathon, I think, in.
So it's weekend of the 16th. We're at hackathon in New York. If you want to dial in remote, also visit here if you're interested.
Yeah, that's it.
Yeah. So nice work, everyone, being ready in time. We can now have lunch. Maybe not. So yeah. We've got you make queue over there.
Hello everyone, I'm Linus. This is my Chromebook. I got NixOS running on it a while ago, and what's nice about it is it's an ARM-based device, which means that it uses a lot less battery than Intel-based devices. Also, it's cool because it's not Intel. Yeah, so I thought I'd just see if I can show what it looks like at all. I'm not sure it'll automatically. Does anyone know if Slim automatically turns on external displays? Okay, I'll need to fiddle with Randa then, but right, there we go. So this is actually that font's a bit small, isn't it? There we go. Yeah. So as you can see, it's 64-bit ARM, and it runs NixOS quite well. So if I want to play NetHack, I can just use Nix shell, and thankfully almost everything is in the cache. Thanks to Graham, and and no thanks to the internet connection here. Yeah. So it's pretty nice. I don't need to fiddle around as much with building stuff for hours on end, like I did with my previous Chromebook, which was 32-bit ARM. And I'm very happy with it. So if anyone's interested in trying something fairly different in terms of hardware, I can absolutely recommend getting a Chromebook and trying to get NixOS running on it. There you go.
We can, but we can fit in one more, right? You wanted to go, right? Also, for all of you who are now shedding tears, I mean, tomorrow is the hackathon day, and so we can easily fit in any kind of lightning talk that anyone wants to do, right? So.
Test, okay. So I'm not sure if the DisplayPort adapter actually works, but I can, to make it very short, also just talk about it. You all have your laptops with you, or the man next to you, or can do it for you. So I wanted to shortly introduce this little side project that we have here, which is all about building static executables using Nix. The first motivation for that was to build static Haskell executables because, well, there are lots of packages that you use in Haskell usually, and you might have easily 300, 400 dependencies, making from very large Nix closure sizes essentially. Another thing is that we want to have in the Haskell world static executables in general because we want to deploy stuff very easily. We are very envious of Go being able to provide static executables out of the box, and of course we want to have something like that as well. So we found at some point that this is very difficult because glibc does not, which is a dependency of the Haskell runtime, for example, does not make static linking very easy. In fact, it's actually discouraged. And that means that if you want to have a good experience with static linking, you need to use different libc, for example, Muscle. So getting Muscle available before, there was a feature in Stack, one of Haskell's build tools, which was that you could build in an Alpine Linux Docker container, which provides that. Unfortunately, that one lost support for GHC some time ago, and we really wanted to have static builds back. So instead, I built this thing that does that using Nix. So if you go to Nix packages issue 43795, alternatively, you can go to my project repository, github.com/nh2/static Haskell Nix with minuses in between. Then you can see that effort in general. The summary so far is we've managed to write a little bit of an overlay style thing that supports building like 97% of the Haskell executables that are on Stackage statically. So you can ask for any random package in a static fashion. So for example, let's say stack or dal or hsyslog or whatever, you can have them all as static executables and then easily put them anywhere. We depend heavily on that muscle-based tool chain that some other contributors and Nix packages have been working on a lot in 2018. We saw that in the other talk before. This is extremely useful. Without this, this would not be possible. And what this now eventually turned into is that on Nix packages issue 48803, there is an effort to make an overlay, or actually make an overlay in Nix packages itself that provides a whole bunch of executables in NixOS as static versions. So you will just be able to say, give me whatever executable available usually on Nix packages, but give me the static version of that. So we want to make static linking very, very easy, not only for Haskell, but for everything else. And yeah, if you want to deploy something very easily, this might be a thing for you. So wherever you can, please help us get this done and lead to the return of static linking on Linux. That's it.
All right, so I think that that really concludes our food of thought in terms of lightning talks. So let's move over to actual food and enjoy lunch.